In this lesson, we're going to talk about inheritance, which is what we use when we have code that we would like to share. Why do we use inheritance? It's because oftentimes we have many classes that contain functionality that's related. Inheritance is a means for us to share that code that's common and optionally extend it or override that code for specific needs. It's very much tied into polymorphism. If we want to extend a class via inheritance, we have to take an existing class, which we call the base class, and then in another class, we reference the base class. The new class is called the derived class. It inherits from the base class. The derived class can access its own members, but it can also access non-private members of the base class. If you want to declare a derived class, you define the class just like you normally would, public class, class name, and then you put a colon, and then you put the type of the base class. This is exactly the same syntax as implementing an interface as we saw in the last lesson. A derived class is said to extend the base class because it can add additional functionality. A derived class cannot delete any of the members that it has inherited. Any of those public methods and members, they have to be used. They have to be available. You can access members of the base class the same way you access other members. When you're using IntelliSense in your code and you hit the dot keyword, you're going to see all the public and protected members of the base class as well as all the members of the derived class. Inheritance versus an interface. This is a common interview question. A class can only inherit from one class. It can implement as many interfaces as it desires. You just separate them out by commas. Inherited classes share their code, their members, with their derived child classes. Interfaces have no implementation code. So the common interview question is, what's the difference between inheritance and using an interface? Interfaces don't share code. You can only inherit from one class, but you can implement as many interfaces as you want. The second part, as many interfaces as you want, is the reason why developers in C# tend to reach for interfaces instead of inheritance. If you want to share code via inheritance, the derived class gets access to all the public and protected members of the base class. So from your developer's perspective, it does look like they are really embedded in that class. Over to the right is a code sample of this. I've defined a class called employee that has an ID and a name. And then I've created two derived classes, salaried employee and hourly employee. And you can see that after the class name, there's a colon and then a reference to the base class of employee. The salaried employee has an extra property called annual pay. The hourly employee has an extra property called hourly rate. Then down here in my code, I'm instantiating a new hourly employee. And you can see that that variable, that object, has a name and an employee ID, which it inherited from its base class. It also has the hourly rate property that it extended from the base class. There's two keywords we have to deal with when we're working with inheritance: virtual and override. These are optional keywords. If you don't declare a method as virtual, it's going to behave like a normal method. However, if you put virtual on a method, you can allow your derived children to override it using the override keyword, and then they can provide their own implementation. And if you're doing inheritance down a chain, you can have as many overrides as you want. The highest override is going to win. And you can call back up the chain using a keyword called base. And I'm going to demonstrate that to you later. Let's look at a virtual and override sample. In this code, I have a base class called Polygon. And it has a virtual method called draw. And all it does is print out, I am drawing a polygon. Then we have a rectangle class that inherits from Polygon. and it also has a draw marked with the override keyword. In our program main, you see that we can instantiate a polygon P and assign it to a new rectangle. Those types don't look like they match. That looks a little weird to us since we've been working with C# for a while. But in the case of inheritance, because rectangle inherits from polygon, a rectangle is a polygon. So those types are equivalent. They're compatible. Even though it's a type of polygon, when we do p.draw, it's going to print, I am drawing a rectangle, because P is a rectangle and draw has been overridden. Now if we want to use the base keyword, this is the same code as before, except that in the rectangles draw method, I have added a call to base.draw, and then I print I am drawing a rectangle. Now when we call the draw method, the rectangle's draw is still going to run, but when it hits base.draw, it's going to run the polygon's draw method. So it will print both I am drawing a polygon and then I am drawing a rectangle. So whenever you're overriding, you can always use base to call a method. And we actually have a sample of this in our RPG inventory coming up. An abstract member of a class is a function member that happens to be marked with the abstract keyword. Abstract members do not have an implementation. The signature ends with a semicolon. In this way, an abstract member is very much like an interface. It just happens to be an inherited class. However, any class that's derived must implement that abstract member. And a repercussion of this is that abstract members require that the class also be marked as abstract. Anything that's marked as abstract cannot be instantiated. You can't use the new keyword with that class. Because if that class has abstract members that have no implementation, if you created it, you would have a method that wasn't finished, that didn't have any code in it, and that would be nonsensical. So if you have any abstract members, the class must also be abstract, and you can never use the new keyword on an abstract class. So let's look at an example of this. Let's imagine that we've expanded our shape program and we have many shapes, and we wanted to put all those shapes into a single array and be able to loop through that array and call draw. If we didn't have inheritance and polymorphism, we would have to create arrays for every type of shape, and we'd be juggling all these different arrays in memory. The better solution in object-oriented programming is to create a base class of shape, which is abstract, and then any class that implements shape must provide a draw method. So imagine that instead of console.writeLine, we were actually drawing a triangle out on the screen. If we had many shapes, I could create an array of type shape, and then I could put triangles, squares, rectangles, ovals, all of those different shapes inside the array, and use a for each loop to loop through each element and call its draw method. And because that draw method was overridden, each shape would call its appropriate draw method. Sealed is a keyword that you can put on a class when you don't want it to be inherited from. This isn't a very common keyword to see. You usually only see it if a developer's working on an application program interface and they don't want other people tampering with their classes. In most internal business applications I've seen, you almost never use this keyword. I mentioned the protected keyword. So far we've been working with public and private members. Public, anybody can use it. Private, only the class can use it. Even if another class inherits from you, that derived class cannot see private members of the base class. Protected is a keyword you can use instead of public and private. And protected means the member cannot be seen by other classes, but it can be seen by derived classes. So it's a little bit more granular control over who can see it. My children can see it, nobody else can use it. This is going to make a lot more sense when you go through the live coding exercise coming up next.